I knew I already talked about a lot about the comparison between the double integer and Boolean. Right. On this video, I'm going to talk about one more. Right. So the title of this is integer tag versus bit group. Right. So basically, I'm talking about when we define a DIN tag in Allen Bradley PLC. We can use this DIN tag in two different ways. Mostly, very common way, we refer that as a double integer tag, right? But also we can use that as a group of bit, right? Because it has 32 Boolean tag within it, right? I already talked about a little bit before, right? So in addition to store numerical values, right? So double integer. So integer can also encode multiple pieces of information, right? It's almost like an encoder. You will see the example of what I mean by encoder. So different state and different status onto one tag. So you concentrate multiple pieces of information into one tag. By using this technique, you can simplify your logic, right? So because you only referring to one tag, right? Let's look at more detail, right? So if you operate this DIN tag as an integer tag, so all the states are exclusive to each other. So the example of this will be, remember we talked about the status on the trivia game, right? So it has 4 different values: 0, 1, 2, 3, right? 0 is reset, 1 is fault, jump start, 2 game start, 3 yellow light, right? So with different value, it represents different states, right, of the player, right? So they mutually exclusive to each other. So that's operate as a DIN tag. You can also operate it as a bit group. So first I want you to know from my experience, this way it's not very common, but it does exist, right? So it has its character, it's the upside and downside, right? So with this method, each bit, each Boolean tag within the 32, right, if referred individually in the program, so different states could coexist. That in contrast with this, exclusive each other, right? So I'll talk about the drawback later, right? So the example is on the next slide. So let's have a look at that. So on the next example, next slide. So I use the garage door as the example, right? So if you remember that with the garage door lab, we have 3 status indicator for the motor. Motor could moving up, moving down, or stop. 3 different states, right? And then in the program, right? So that will be the output for motor up, motor down, and motor stop, right? So this is the version 1, how we design that, because that's also this is could connect to the physical device, right? So that's Boolean. But if we create a motion double integer tag, you can see here. So similar to the integer tag we compare with 100, or on the trivia game, the player's status, we can assign different values to represent different state. With value 0, we stop. Value 1, up. Value 2, move down. Right? So in this way, we use one double integer tag to represent the 3 different states of the motor. So they mutually exclusive to each other. Right? That means when it's moving up, cannot be moving down in the same time, right? When it's moving up, it's not stopped, right? So any one of these three states, right, it's in comparable mode with the other two, right? They cannot be true in the same time, right? And by the way, so if you remember when you design the HMI on this part, you have to create three text objects, right? Remember that lab on the HMI, you create three different tags and set up the animation, visibility animation. Then you can overlap all the three objects together in order to show them, right, at a different time. But if you have this design, right, you could have a different way to do it. Remember with the compare, similar to compare with 100, right? So you could have one multi-state indicator, so with three different values to represent a different color, different caption. With value 0, you have motor stop, right? With value 1, motor up, value 2, motor down, right? So in this way, you don't need to create three. You only need to create one. Then that will be done with that curve, right? In the similar style with the positions on the door, we have four different indicator line: open, close, ajar, sensor fault, right? Four different combinations on here. So if we keep using the same style as a double integer, right? So we can create another tag called light, right? Which is a double integer, right? With four different values. Same sort of idea. So we can combine all these four, right? So now you can see they were four of separate multi-state indicators, right? But if you design in this way with the light, you could only use one multi-state indicator to do that, right? So this is the first way from the previous slide. If you remember, that's what I referred to as a integer tag, right? So we create two tags. One is called motion, the other one is called light, right? So this one has three different states, this one has four different states, right? So each individual one, they exclusive to each other, mutually exclusive, right? So that's what I mean by this. You could have this type of design like this, right? Then let's look at the bit group way, all right? Bit group, I didn't show everything on here, but I think you can figure out, right? So you can see here, it still have the motor up because, like I said, that could connect to physical output. So that's why we need to keep them. We have as a boolean, right? So that's here. But this time we create a status. This tag itself is a DIN tag. It has 32 bits in it, right? Then if you want to access each individual bit, you use dot, right? Like status dot 0, status dot 1, right? So in this way, you can all the way up to 31. If you remember on the different video, I mentioned that when you have the ONS, right? When you have a lot of ONS one-shot instruction in your program, the tag you assign to the one-shot, each time it should be a different one. So that will require you create a lot of Boolean tags. If you are tired of creating different names of that, I remember I used dummy. Right? You can even give some silly name on there, right? Dummy, which is double integer. Right? You can use .0 as the first one, .1 with the second one, right? If you have a lot of one shot, right? Similar idea as this. You use dot to access each individual bit or Boolean tag inside. So with this garage door design, right? We use the 4, 5, 6, right, to represent the motion in door. Then we keep the lower 4 bits from dot 0 to dot 4. We use that as the indicator on the for motion lights, right? So in this way, you can see we use one double integer tag to include not only the motion on the motor and also include the light, the positions of the door. So in this way, you can see you could have potentially, all right, potentially when motor is moving up, let me clear up a little bit. So when motor is moving up, you could have the dot 4, this bit turn on. But in the same time, right, the ajar light, ajar will be the, I think this one, ajar, right? Ajar is here when turn on. So that means on the same tag, right, you could have dot 2 as a 1 and dot 4 as a 1, right? You use use one tag to represent two different information, piece by multiple pieces information together side by side. All right, let me clear out and also put them side by side on here. All right, so again, this is just some I think, in my opinion, it's more advanced topic. You don't have to fully understand it if you feel it's difficult, right? But just throw there that you to understand. You have the options. This kind of design, right? If you look at it right now, right? If you use the motion with double integer value, you cannot also include with motion include the position on the 4 lights together. You cannot, right? Because you're using the value, right? Unless you find a more complicated way to do that, right? More straightforward way is that you use 2 separate double integer tags with different value to represent that, right? As an encoder, right? So that is encode, right? But if you really picky, you want to have only one double integer to have both motion and light positions information into one. You could have this second way, bit logic. In this way, you would have to use the dot 0, dot 1, all this, right? In this way, you could have them coexist, like what I mentioned, right? You could have the motor up, on, and a jar light on in the same time. Or once you reach to the top, you could have the motor stop and door open in the same time, right? More than one bit turn on. Right? So that is what I mean by the encoder, right? So as you can see on the drawback is that this one is limited by 32, right? A possible confusion caused by both bit and integer instructions. So that means if somewhere in your program you not only you refer the status as the dot different bits, you also use that on the double integer instruction. You use equal, or even worse, you use math instruction to operate on that. That's going to be a disaster. Right? It's too complicated. Nobody can trace that, right? So that even you can, it's not the way it's supposed to be, right? So this is just some information I'd like to talk about. The last one, all right? The last one, I made a little bit of video in the lab, all right? So in this video, I want to talk about again the double integer and Boolean tag, right? So 32 bits within the double integer. So in this example, I created a tag called stack, which is a DIN tag. Can be used by OTL, OTU because we use the dot, right? You can see here dot 0, dot 1, right? And all the values of 32 bits retained retain the same after power cycle. So that means we understand, we already tried that in the lab with latch, right? If you latch it, you turn down the power on the PLC, and then once you power back on, that bit is still 1 because it's backed up by the battery, right? So then I was curious, right? So that's why I did this in the lab. I have to use the real PLC to power off and power back on to try it, because once we use the large instruction operate on one of the bit with the double integer, I want to see what exactly happened, right? So this is why I made this video in the lab, and let's look at it together, right? So I will explain what's happening here. So right now I'm online, right? I'm online, so I have these 3 bits from the one double integer, right? I use .0 as a trigger to latch the .1, and then I use the last bit .31 to do nothing. This represents no operation, right? So I just want to see the value, right? So right now, I just toggle this the trigger and then the latch bit on, right? So let's see what happened. And so yeah, I just want to read that, right? I already explained that. So now I toggle this 31. So on the bit 31 is also on, right? And I believe I also toggle this one off. That's no operation, right? So let's see. Yeah, .0 I toggle back to off. So now you understand, right? So what happened with the program, because it's latched, right? And because it's latched, the trigger is off, is still 1. And this one, because I toggled it, it doesn't have any consequences, right? I just want you to see the .1 and .31 was both on, both value 1 with the bit. Now I want you to pay attention on here. This is the remote run, right? That means PLC power on, right? So I'm going to shut down the power. That's what I see. There's a pop-up window, right? Then let's see what happened. Yeah. So this is just what happened with the power off, right? I could acknowledge it and try to get back online. Right? So I click the pull down, then you can see I choose go online. Regarding this, I have to explain a little bit, right? On the Studio 5000 video, I explained this. So you have 3 options on the first section. You can go online, upload, download, right? Normally we use download, right? We program offline. We want to change the content of the PLC with your file, right? If you go the other way, there will be upload. Go online, that means whatever you have with the file, you use just as it, and you try to match with what is currently running on the PLC. You don't do any changes, right? Because when you download, you use the offline file, change the online, the PLC controller file. If you go upload, you go the other way, you use the PLC content to change whatever you have offline file with that. When you go online, you're trying to ask PLC and the software to see if they match. They match, you don't change either one of them, just get back online on the status. So the first attempt, it's going to be fail, because you can see that right now I just turned back on the PLC controller. Of course, you couldn't see that, but PLC will go through a self-test process, right? So you can see it right now is waiting. So Studio 5000 is trying to establish the communication with the controller, but the first one is failed because the self-testing process haven't completed yet, right? The PLC controller is still busy, right? So this is why it failed. Then I tried the second time go online again. I didn't want to change anything. I didn't want to change it to PLC. I don't want to change it to the offline file. You can see this is what I mean by this, right? So I believe I draw that, right? So this is the same as before. Yeah, I should write down before here. So before we have both bit on, right? This bit I turn off, if you remember, right? Before I turn power on, right? So this is what happened. So what happened over here is that Again, this is just because curiosity. I just do an experiment. I believe because we have the 1 bit of the double integer being used on latch, so that turns out all whole 32 bits being backed up by the battery. So that's why even this one we didn't use latch, we just use exam on, right? But before power off, I turn it on, value at 1, but after power back on, it's still value 1 in this, right? So it's just very interesting. I found this one out here. So then let's look at the other one. I did another experiment. Again, I just want you to understand the connections between double integer and Boolean. Right? So in this one, I add one more run. So that online edit finish. Right? Okay, so let's look at the comments. CLR can clear all the bits value without using OTU. Remember the OTL, we talk about that, once you latch it, you cannot set the bit back to 0 by the trigger, right? You already see that. Or even the power, you turn power off, as long as the battery is working, you cannot change back to 0. By that time, I mentioned that pretty much the only way is that to use OTU, unlatch the bit. But now we try a different way. So this time we use the CLR, which is numerical instruction, to clear the double integer step to 0. Right? So to see if we can clear this bit to 0, right, without OTE. That is the purpose of this. So, and this is what we call the system first scan. So after we power off and power back on, before the program being scanned normally, the system will do the first scan. Right now, before I turn power, this time maybe I should record that. Right. So we have this bit tag value 0, this bit tag value 1, this bit tag value 1. Right. You see that. So I'm gonna play the video, the power off. Right? Yeah, so you can see right now power off. Right? I'm going to try to back on again. So this time, same as before, right? I cannot go online at first attempt because PLC is still busy. Right? So then I use the time waiting to explain a little bit about that. The first scan is a very interesting concept. I explained that in several videos on that, right? So it's a system control. Right? That's why it's S, column FS. So basically, we can check this bit to work on something before your normal program being executed, right? So now this time I will get online. Once I get online, you will see on here, right? This is what you see here, right? Clear 0. So that, remember what I said, the system scan, right? Only for one scan, the very first scan by the system, right? Even though those 2 bits was 1 before, right? But because the first scan cleared that to 0, then even without OTU, the dot 1 will be cleared to 0. Right, so that is basically what I'm trying to prove on that, and not trying to prove some big concept. It's just interesting to do this sort of comparison. Right? Also, again, this is currently the implementation from the Allen Bradley PLC Studio 5000. I don't know what they're gonna do in the future if they can continue doing that, right? I think this makes sense, right? Also, I don't see any point if they make change in the future, right? Okay, thank you.